Hi, welcome to our project. We are team 2 and our project title is Cars Data Analysis, and our team members are Avirag Srivastava, Kit Kaili and Vigneshwar, myself. So basically what we are trying to do in this project is we are trying to classify the cars database into 4 different classes: unacceptable, acceptable, good and very good. So we are actually trying to classify the cars based on the different features, around 6 different features, and we are trying to apply a softmax regression, which is actually a variant of logistic regression meant for many classes. So we'll start with the pre-processing and move on to regression modeling, and we also cover, in the end, we also cover about underfitting, overfitting and loss versus error. So let us go and see some more information about the data set. So we actually download this data from UCI machine learning repository, where our data set is ideally consists of the target variable called acceptability. So we based on the given input features, we try to say if the car is acceptable or it's not acceptable or it's very good. And so we actually have 4 output classes, and the attribute, I think we have come down to 6 different features, which are buying, maintenance. This buying and maintenance covers the cost factor, and doors, number of doors the car has, number of persons the car accommodates, and the size of the luggage boot, and the safety of the car. So these are the features that we are going to use, and our data set ideally contains around 1728 records, and there is no missing value, and the total number of attributes is 6. And the attribute values are ranging from, there are different categorical attributes like high, medium and low, and also small, medium, big. And the classes, basically this is the distribution of the data that we have, which is the acceptable features and unacceptable, and it's properly distributed. So let's go back to the code, and we also do use a lot of pre-processing here. So in order to import the data set, we actually use Google's Collaboratory's inbuilt file uploader, and we try to import the car.csv inside. Once we actually downloaded the car data set, we are using the standard libraries like Python, Pandas and NumPy, and also we use the machine learning techniques available in the linear model, which is under sklearn. And let's go to the pre-processing of the data. So basically, since we have our output classes as categorical, which are 4 classes: unacceptable, acceptable, good and very good, we are actually converting them into numerical attributes, which is 1, 2, 3 and 4. So we are actually replacing them. And also the buying and the maintenance attributes, these are the 2 attributes that covers the cost aspect of it, and which ideally says it's very high cost, low cost and medium cost. So again, we are converting this categorical attribute into a numerical attribute. So once we loaded the data, this is how the initial data looks, where we have different categorical attributes, and once we find this thing, we will actually try to pre-process them and try to replace all the categorical attributes with the standard attributes. And once we have started it, we are actually going to use PCA, which my friend here will explain.
So for PCA, there are 6 features, including buying, maintenance, door, persons, luggage route, and safety, contributing to the acceptability. But we would like to apply PCA to explore the intrinsic feature dimension for the labels. But before implementing PCA, we noticed that for the label in the middle, we have to add some weight on each entry in order to make it more common factored. So we multiply each column feature by acceptability to make sure every entry is meaningful in the sense that we're working with. After that, we drop the acceptability because there are only 6 features inside. And after each feature column is given an acceptability weight, we apply a scatter graph to see how each feature is contributing to each other. Here is the graph. So by the graph, you can see that there is a linear relationship between door, persons, luggage boot, and safety. But in order to see if this observation is correct or not, we have to create a PCA principal. So what I'm doing is I take 6 components here, and then I put it in the PCA function. And after that, we'll see a graph showing how each feature is contributing to each dimension. For example, in dimension 1, we can see that there are 6 features contributing positively. Okay, so from the above table, we know that the first 4 components can explain around 93% of the variance in the dataset. With 6 components used, we could explain more than 100%, so we propose there is an overfitting in our dataset. We will see if this is true or not. And then we need to plot a elbow graph to see how many components are optimal in our dataset by using PCA. So you can see that the elbow occurs between 1 and 2, so we choose 2 as our component number here. By using 2 components, and then we can plot a PCA graph right here. You can see that maintenance and buying are pointing in a different direction dramatically. However, by doors and other 3 features are pointing to the same direction in the middle, which means that there are 2 major components contributing to our labels.
Very good.
After that, we'll train the model, and my friend will explain it later.
So now we are trying to train the model using the 2 methods. First, we are doing it using Newton solver. These are our features in our data set along with the label output, and we are using an inbuilt API of sklearn, which is known as train test split, to split our data into training set and test set. We are keeping the training size as 70% of the data, and the remaining 30% will be regarded for the test set. So currently we are calling this method logistic regression of the sklearn package, where we are actually using the multi-class, because as output label is more than 2 classes, and here we are specifying the solver, which is in this case is Newton solver, and iterations that we are keeping it as 500. So we just calculate this, and this will return us the accuracy score. So we just predict, we have the predicted value and the actual value, we compare this and we get the training and the test accuracy. Along with this, we are also calculating the train error and the test error, which is nothing but the 1 minus of the corresponding accuracy. And for the calculating loss for the training and test error, we are using an inbuilt API called as log loss, where we are actually passing the true value and the predicted value. So I'll just try to run this. So as you can see, the results after running the Newton solver method, we get the training accuracy as 82% as well as the test accuracy, and also we get the loss as 37 and 44%. So the next thing that we are going to demonstrate is the same training of the model using stochastic gradient descent. So the code is exactly same as the above, where we are using the 70% of data as training. The only thing that we change here is the parameter that we are passing as the solver, where we are mentioning is it as SAG, which stands for the stochastic average gradient descent solver. So we simply try to run this as well. So as you can see, the result of the stochastic gradient, the training and the test accuracy, we get 84 and 80% with the corresponding losses. So this is another method with which we can train our model. So the next thing that I'm going to demonstrate is the problem with the underfitting and overfitting. So here what we are, the logic we are trying to achieve is trying to demonstrate our underfitting using the different combination of our features. So as you know that we have 6 features and one output, then we will try to take different combinations as number of combinations as features. So I'll just try to change it to 2. So I'll just try to run it. So as you can see, this is the best feature set which has 2 features and the one corresponding label output. So as you can see, it has training accuracy 76 and the test accuracy is 78%. So as you can see in the report, we keep on increasing the number of combinations. So this is with 2 features, this part. Then we move on to 3 features, and as we keep on increasing, the test accuracy keeps on increasing. So we get a better training model by increasing the number of combinations of the features. So I'll just simply go to 6. So the so the 6 feature combination is the best in our case. So I'll try to change it to 6. As you can see, the test accuracy has increased to 82%. So this is addressing the underfitting problem. As you can see, the test accuracy has increased from 2 feature combination to 6 feature combination. So this is basically trying to get an optimum model with the optimum number of features, which is 6 in our case. So this is again the same thing using the stochastic gradient descent. I'll simply run it with the 6 combination feature. So as you can see, we are getting a good test accuracy of 83% with our 6 combination feature. If I change this to a lower number of combination, it should decrease the test accuracy. We'll just try to demonstrate that as well. So as you can see, it has drastically decreased from 82% to 74%. So this is trying to address the underfitting problem. Then the next and the last part of our project is training our model using the cross-validation method. So for the cross-validation, we are actually using an inbuilt API logistic regression CV, where the CV equal to 10 means the number of folds, the number of containers we want, and we are using a maximum iteration of 1500. So first we are trying for the Newton solver method. So I'll just try to run using this. So yeah, so this is the our output. As you can see, this is like the best test accuracy that we have got till now. So the cross validation actually works in our case with the number of folds as 10, and in the Newton CG case we'll also test it with the stochastic gradient, the same concept of keeping number of folds as 10 and maximum iteration as 1500, and we'll try to see what is our training and test accuracy. So as you can see, it's taking some time because the iteration is 1500. Okay, so we got our final output, and as you can see, the training and the test accuracy as 82 and 82%, which is quite good considering our model. So this is the final demonstration of our project. And okay, thank you.